Greetings from the Engerati studio. This is Carol Stimmel at European Utility Week 2016. And in the studio today we have Guy Konings, who's the Market Manager of Business Development at Stedin. Thank you for joining us today. It's nice
Thank
to
you
have
for
you.
the invitation. Yeah.
So before we got on film, we were sort of just talking a little bit about your power-to-chemical technology. I'm really actually very excited about talking about this a little bit. So if you could just briefly sort of explain for our viewers what that is and what your goals are with this particular implementation.
Okay, well, we are talking about power to chemicals, and that's a relatively new technology where we convert electricity, especially renewable electricity, into chemicals, and in this case ammonia. And ammonia is one of the most effective energy carriers that you may choose from. And why are we doing that? Because we as a grid operator, we own electricity and gas networks in the Netherlands, and we see a lot of renewable power coming onto this grid. So that means for a grid operator that we normally need to invest a lot in grid capacity, increasing grid capacity, putting copper cables in the ground. And for us, it's quite interesting to work on other conversion technologies that create flexibility in the grid.
Right.
And power to chemicals is one of the most interesting, fascinating ways of doing that. And it allows you in a 50 to 100 megawatt really big storage to create that into the grid. So that's the reason that we do it. It's relatively new, but we're very excited about it.
That's actually quite a packed statement. You said a lot in there I want to dig into. So with power to gas technologies, as I recall, one of the impediments was that utilities might be electricity and they might not have ownership or domain over the gas grid, and so that was an impediment. But as we start to talk about that, why don't you walk us through how this works? Is it like the hydrogen conversion?
It is.
Okay, so you're taking the excess from
the excess
wind?
Power of excess electricity or renewable electricity, and in some circumstances it might not even be excess, but it might just be all the renewable electricity that normally is being fed into the grid. We take that and we convert it by means of electrolysis into hydrogen. But hydrogen is a very difficult element actually to store, so we convert the hydrogen into ammonia. And that's by using nitrogen from the air, and that's the most abundant thing in the air around us is nitrogen. So we convert the hydrogen with nitrogen into ammonia, and that's a very convenient chemical to store.
Does it happen all at once, or is there some sort of...
It's a two-step approach.
But so you're storing the hydrogen, you're doing the electrolysis, and you
and
end up
then
with hydrogen.
And directly convert the hydrogen in a specific, it's the Haber-Bosch chemical process, it's well known all over the world, and you produce ammonia.
And then you pump that into your gas grid in some
proportion?
No,
the ammonia is really being used as a renewable chemical, so we extract the electricity from the grid. So it's a conversion technology. Okay. It's not a storage technology.
So slightly different.
It's slightly different, yeah.
Okay, well that's pretty, that's new. And so can you talk about the role that this sort of, let's talk about energy storage in general. So you're already doing some novel things. So talk to me a little bit about what you see as how this new exciting development is taking place, and talk about that in terms of energy storage technology.
Okay. Well, there are we have a lot of energy storage technologies, obviously, batteries, compressed air, etc. We are experimenting a lot with it. In fact, we do have a lot of pilots where we make work of battery system, how do that fit into the grid. But we see a certain limit to that. Because if you talk about large volumes of electricity that you want to store, it's perhaps more important or more interesting to convert them into an energy carrier, as for instance ammonia.
Right.
And that means that you can create an energy carrier, and by doing so we connect different industries. So we are coming from the electricity industry, we own electricity grids and as well as gas grids, and we connect this industry to, for instance, mobility, for instance the chemical industry. And they are also looking at renewable chemicals. Mobility, for instance, we are also investing in power to hydrogen, where the hydrogen becomes available for mobility. And it's really a conversion technology, because we see that with only storage we will not make it. We also need conversion.
So that's really interesting. I'll tell you, that's not a conversation I typically have, because what we're usually talking about is for the past few years, it's always been storage is the killer app. Storage is what makes a distributed grid happen, renewables happen.
Yeah.
So you're taking that idea and you're extending it, right?
If you really talk about the future, and there's so much renewable electricity coming online, whether it's in Europe or in the remote renewables in areas where it's quite inexpensive to produce renewable electricity, then for some way or the other, you have to also transport this electricity, and you can only do that with energy carriers that are feasible, and ammonia is one of them, because only storing it into batteries and extract it from storage systems such as batteries in the times that you need it might not be enough. Seasonal storage with batteries is too costly, but seasonal storage in chemicals, so store the electricity in ammonia and during the season, and in the season that you need it, convert it back to electricity, which is also a possibility, gives it a good chance.
Okay, great. This is innovative stuff. Tell me, do your customers even, are they aware of this? Is there any sort of customer-facing component to this at all?
Yeah, absolutely. We're a grid operator, so our customers, they are attached to the electricity or the gas grid, but also these customers, they talk about energy. They're not talking about electricity or gas, they talk about energy. And also they come to us and say, well, we have a grid connection, but we're actually worried about, we are producing ammonia from fossil sources. But that becomes quite critical if CO2 prices will increase. So could you help us out? What's the next thing? And if we then say to them, okay, you can also tap into electricity and produce ammonia or other chemicals from electricity, they're quite interested in that. That's why we also cooperate in these type of projects with a lot of international companies.
Do you want to talk a little bit about some of your projects?
Well, one of our interesting projects is, for instance, power to gas. It's producing hydrogen on a specific location in our grid, where there's a lot of windmills, a lot of solar, and normally we should invest in expanding the grid capacity in order to absorb for all this electricity and to transport it to somewhere else. And actually we've said, well, that's what we've been doing already for 80 years now. We could also invest in a power to gas facility where we convert the electricity into hydrogen and we offer that to mobility clients.
I see. Yeah.
And one of our lead clients there will be Connection. It's Transdev. It's a large European public transport company, and they are converting their buses, their public buses, to hydrogen fuel cell buses. So they need hydrogen as a fuel.
Yeah. That's, so it's a real advantage for you to have the gas and electric kind of facilities under your auspices. Do you also use the hydrogen to sort of create a cleaner burning fuel for generation?
It is. The most convenient and the most easy way is to store the hydrogen into the gas grid, so that you connect the electricity grid with the gas grid. A gas grid, of course, has a lot of more capacity than an electricity grid. However, if you put the hydrogen into the gas grid, well, you are depreciating a little bit the nice hydrogen that you have, but still you can use the gas grid for transporting hydrogen. It's quite interesting. Yeah.
It's really
just connecting grids, creating flexibility. That's where it all is about.
Yeah, because I think it's clear the conversation has been for a long time that we need to break down these silos, and that's typically that's a business decision. It seems to me that over the past few years we're seeing innovative technologies, whether about what you're talking about here or even things like analytics, starting to create more unified utility scenario, which I think is probably pretty good for business, and it's a new way of doing business. And I think you probably have some learnings that could benefit some other utilities. Would you be able to share some of them here?
Yeah, the biggest learning that we have is exactly what you said earlier, is that we think in silos. If you walk around also at European Utility Week, a lot of people talk about electricity. We are used to think in electricity, and also we are used to look at solutions that come within the electricity domain. And what we are actually seeing now is if you tap our challenges, if you connect them to the challenges in other industries, for instance mobility, for instance chemical industry, for instance food, then you might come up with newer solutions. So get rid of these silos and start working on the edges of the world that we are used to working. That's the most critical thing to do.
Yeah. So it's sort of interesting. We used to. have trouble, I think, because of the sort of specialized domain of electricity, energy, of understanding how to work and learn from ancillary markets or other markets, adjacent markets, not ancillary. So adjacent markets like telecommunications, that sort of thing. And I think, finally we're overcoming that. And I think a bigger risk now is losing our own specialized knowledge to more general thinking. And what strikes me about your innovative process is it's very energy centric. You're taking the assets you have and looking at new ways to use them and provide value. I think that's incredibly interesting. And Guy, I very much appreciate you stopping by today and sharing with me. This has been a big learning experience.
Thank you very much for this invitation.
Yeah, enjoy the show.
Okay, great.